Okay, so I'm going to be doing 4.9, 7, 8, 9, and 10. And what I'm going to be doing is taking the function and finding the antiderivative of the function. So, oops, the general rule, we can rewrite this as x to the n. So if the derivative is x to the n, then the antiderivative is going to be x to the n plus 1 all over n plus 1. That's a general rule. So I'm just going to be applying that to this. Really easy. And I'm going to be calling it capital F of x. It's going to be the notation I'm going to use. So I'll take this, 7x to the 2 over 5, and this is my n value here, so I'm just going to add 1 to that, plus 5 over 5 to make it easier for me, and then I'm going to divide it all by this n plus 1, so that's going to be 7 over 5. Alright, and then this part follows the same rule, so I'm going to do add 8x to the negative 4 over 5, adding 5 over 5, which is 1, and then dividing it all by this n plus 1, which is 1 over 5. Okay, now I'm going to go and clean this up, simplify it a little. So capital F of x is equal to, so 7x to the 7 over 5. And then we can rewrite this as times 5 over 7, right? So the 7's will cancel out, but I'll rewrite it nicer down here. No worries. But you can, like, just cross it out. So it'll be 5x to the 7 over 5 plus 8x to the 1 over 5. And that'll just be times 5 over 1. So rewriting this, capital F of x is equal to 5x to the 7 over 5 plus 40x to the 1 over 5. Oh, and I forgot to include this in every step, but you probably should, plus c, which is our constant term that may or may not be in there. We don't know, so we have to add it. So what I like to do when doing antiderivatives, if possible, is go back and take the derivative of whatever I found, just to make sure that matches up with the original function. So I'm just going to do that now, taking the derivative, using the power rule, that kind of stuff. So 7 over 5 times 5, right, x to the minus 5 over 5 is going to be 2 over 5. These will cancel out, plus 40 times 1 over 5, x to the negative 4 over 5, because we're subtracting 1, and then plus c, which is just going to be nothing because there's no x value attached. So it's going to be 7x to the 2 over 5. Sorry, I didn't do my proper notation, but there you go. Plus 40 divided by 5 is 8x to negative. And, yes, matches with my original function. So that's question 7. Alright, and now moving on to question 8. I'm just going to write it down here. So 8, so our original function is x to the 3.4. Oh, you can't really see that. X to the 3.4 minus 2. I'm just going to move my light. So that, nope, can't really move it, but there we go. Plus 2x to the root 2 minus 1. Okay, so using that same x to the n plus 1 over n plus 1, rule, I'm going to go big F of x is equal to x to the 3.4 plus 1 all over 3.4 plus 1, and then minus 2x to the root 2 minus 1 plus 1 all over root 2 minus 1 plus 1. Okay? And now to clean it up a little, f of x is equal to x to the 4.4 all over 4.4 minus 2x to the root 2 all over root 2. Pretty simple. And now I'm just going to check to make sure that I did it properly. So using the power rule, I take it down 4.4. Oh, technical difficulties over here. There we go. Okay. There we go. 4.4 x to the 3.4 all over 4.4. So cross those out or cancel. Minus 2 root 2 x root 2 minus 1 all over root 2. These will cancel, and I end up with my original function of x to the 3.4 minus 2x to the root 2 minus 1. Yep, yay! Check. Okay. Alright. Next one is pretty simple. So almost forgot. Don't do it like me. Remember to add the c during every step, because otherwise you'll forget. But there is a constant term that we do not know what it is because it does not have an x value associated with it, so it's lost. But it's there. It is there. Don't forget it. C might be 0, but it's still important to include. And sometimes I forget to write that down, but don't forget. Alright, 9. 9 is pretty simple. Our function given is f of x is root 2. So, it's like, what's a general rule? Well, we know that if we had an original function, and this is the derivative of the original function, it should be apparent, hopefully, that there was an x associated with this, so our antiderivative is just going to be root 2x plus c. Don't forget the c. And then if we take the derivative, it's just root 2. So yay! Pretty simple. That one's a nice little treat. Same goes for 10. We have e to the 2. This is a constant, right? It's just a constant, so it's going to be the same as this. So our capital F of x is going to equal e to the 2 x plus c. We're not forgetting the c anymore. And then if we go and check, what do you know? Checks out. So perfect. You don't have to check every time. I like to check every time just because it's reassuring. But as they get more and more complicated, it's kind of a pain. And you might not have time on the final. But it's good practice. Don't forget to add your constants for the antiderivatives. It's important, but I forget about it, so I expect other people would, and thankfully I usually catch myself at the end. So if you're not doing it when you go along, at least remember to do it at the end. All right, thank you.